This is Tyler Faulkner with Carlson Software. This video is going to discuss how we can modify grid files to meet a variety of needs. Just to show some examples of what we might want to do to grid files, how we might want to change them. I've got 3 example files here. I'm looking at these in our surface file viewer. I have a green topography grid. I have a red elevation grid showing the bottom of an overburden layer, and a blue elevation grid showing the bottom of some key material. So some examples of things we might want to do with these grids. We might want to clean up the topography. As you can see, we have some missing data out along the corners. I want to extrapolate that. We might want to determine the thickness of the 2 strata layers. What's the thickness of the overburden? What's the thickness of the key material? We might want to calculate a stripping ratio from those thickness grids. And then a step further, if we had quality of these 2 strata layers, we may want to dilute the key material a bit to show what a new diluted quality would be. So we're going to go through some of these examples using grid file utilities. One of the first things that we'll do is we're going to do very simple calculation. I'm going to go to my grids pull down menu, which is in the geology module, a variety of other modules as well. We're going to go down to grid file utilities. You can see we have this dialog here. And grid file utilities, I really like to think of as kind of like a grid calculator. So we're always selecting a starting input. We're going to add some changes to it, modify it in some way, and we're going to save the result. So the first thing I'm going to do here is we're going to select a grid, and I'm going to select my topography grid, open it up, and that is the grid that's currently loaded in. I'm then going to make a change to it. For this first example here, I'm just going to extrapolate that topography grid so it fills in all my null values. And you can see we have a variety of options here for how to extrapolate. I'm going to use this combined option. So I've made the change, and now I'm going to save my result. Now I do strongly recommend that when you make changes to grids that you save as. If we just click save, it's going to overwrite my original, and I like to keep the result separate from the original, so if we need to backtrack, we can. So I'm going to call this topography extrapolated. And just to inspect that surface, anytime I make a grid, I always like to inspect it in 3D. I'm going to go to my 3D viewer, surface file view, and I'm going to first select my topography grid, but you can actually see the result, and sometimes you can see it right here in the preview. So if I look at my topography grid original, I've got the corners that are not shown there, but on the topography extrapolated, we can see those values are filled in. Let's take a look at our topography grid, and then we'll take a look at our topography extrapolated. And you can just see where we've filled in those corners. So it's a very, very simple example with grid file utilities. For my next example, I'm going to do a comparison of 2 grids. I'm going to do a top elevation grid, subtract a bottom elevation grid to tell me what the thickness looks like. So I'm restarting grid file utilities. I'll hit select grid. I'm going to select my topography extrapolated, and I'm going to do a math function on it. So I'll click math function, and here I can subtract either a constant value or I can subtract another grid file. So if I wanted to, for example, take a topography grid and lower it by some amount to model a topsoil, I can use subtract value. But in this case, I've got a moving grid that I want to subtract from it. So I'll say subtract grid, and I'm going to subtract the bottom elevation of my overburden layer. So I have it there. I'm going to click save as, and I'm going to call this my OB thick grid. Save it. And while that grid is still loaded in here, a quick way to inspect just the values, I can click grid info. And so we can see the location of the grid, the X, the Y values, and I can see right there what the average value is. I can also see the minimum and the maximum values. So it's just a very quick way to inspect it. And you'll notice that we also keep a rough history of how this grid was made. So we can see the last little calculation I did there was I used grid file utilities. I used the subtract grid function, and I used topography extrapolated minus the overburden elevation. So we've got just a very quick way to inspect that. The next example I'm going to show is very similar, but with an added level of complexity. I'm going to repeat grid file utilities, select a grid. This time I'm going to take my overburden bottom elevation, perform a math function, subtract a grid, and I'm going to select the bottom of the key layer. And I'll save the result as key thickness. And I've already got this grid made, so I'm just going to override it. Exit out, and we're going to visually inspect it. Key thickness. And with my color by elevation option turned on, I can very quickly see that I've got some areas in the grid where the value is actually below 0. And if this grid is supposed to represent a thickness, that's a nonsensical value. So what that tells me is I simply don't have any key material in that area. So to modify this grid, I'm going to prevent any values from dipping down below 0. Let's show how we're going to do that. We're going to return to grid file utilities, select our key thickness grid, and we have a series of comparison functions. The one that I'm going to use is the max value function. And with this, we're going to take the grid, we're going to compare it to a constant value, and we're going to retain the maximum of the two. So for example, I'm going to go with max value. I'm going to compare the grid to a value of 0, and anywhere it's less than 0, it's going to raise it up to 0. So click OK, save as, and this time I am going to overwrite the previous result. So I'll just call this key thickness again. And let's go inspect it. And here we can see that my minimum value on this scale bar, the last value that's actually labeled is a 0.08, but that scale bar goes a little bit below the last value. But we can see in those areas I'm not going to have anything dipping down below 0. So I've removed the negatives from my thickness grid. Just another simple example. The next example that I'm going to show is going to compare our two thickness grids to calculate a stripping ratio. And what I find to be very helpful before I just jump into grid file utilities and start punching in numbers, I always find it very helpful to first write out the equation so you can just kind of keep yourself straight. So we know that a stripping ratio is a comparison of thickness grids multiplied by some conversion factors to get it in the units that we want. So in my example, I'm going to report my stripping ratio as cubic yards per ton. So I've got 3 conversion factors in here, my 2,000 converting pounds to tons, my 27 converting cubic feet to cubic yards, and my 80 being an assumed density of the key material, converting cubic feet of key material to pounds of key material. What I've done here is I've just smashed those all together into a single conversion value. So essentially I'm going to take my thickness of the waste, multiply it by this value, divide by the thickness of the key material. I'll keep this off to the side for reference. And there's actually multiple ways that we could do this. Once we start getting into more complex examples, you could do this with the step-by-step like we've been doing, where we select, click a button, save the result. I'll start off with that, but then I'm going to show a complication where we might actually want to use a macro instead. But first go here, I'm going to select my overburden thickness grid. I'm then going to multiply that by my conversion value, which is 0.9259. Math function, multiply 0.9259. Click OK. I'm going to do another math function to divide by the key thickness grid. So I'll grab my key thickness, open that up, and I'm going to save the result as stripping ratio. Save it, exit, and we're going to go inspect it. So we can instantly see a bit of a problem here. If I look at my grid, the majority of the grid's blue using these really low elevations, and then I've just got an enormous spike on this surface where these values have just gone through the roof. And what's happening there is the key material has gotten so thin or is completely zeroed out, it's really thrown a wrench in my equation. So if I divide anything by 0, the result is going to be undefined. So what I need to do next is say that anywhere that this thickness is equal to 0, I need to do something different. I either don't want to output a value, or I could set that to some just very large but constant stripping ratio, so I can at least inspect the grid here. And that's something that we can't do perfectly with the click-by-click steps in grid file utilities. So I don't have a way to do an if statement with just my math functions and my comparison functions. So this is where we're going to change gears a little bit. We're going to try out our macro editor. And the first macro that I want to write, we'll go ahead and try it out with our stripping ratio. So we're going to call that our stripping ratio GFU file. So we're going to open that up. And our macro really is an alternative to the quick-by-quick solution with grid file utilities. I still have buttons here on the left to help guide me, but I can also just manually type in the script once I get familiar with it. The first thing I want to do is load in some grids that I'm going to modify. So I'll click Select Grids just like before, and every grid is going to have its own variable name. And I want to be as descriptive with these as possible so that it's easy to review and make changes. The first grid that I'm going to load in is my overburden thickness. So I can use really any name here that I want as long as I don't have spaces in it. Just going to start it off. I'm going to call it OB thick, and I'll pick a grid file to assign to that variable name, which I'll just pick my OB thick grid. I do want to note this variable name does not have to match the file name. You can call these variables whatever you like. Click OK, and it adds 2 lines to my script. First line is a release function, and then the variable name. So what this does is if I had any OB thick variable names already defined, it just clears them out and starts from scratch. Not always necessary, but it's good to have in there. The next line says that my grid variable itself, OB thick, equals, and it's going to load those values from this directory. So it's just saying that's equal to this grid file. Another quick thing I can do, if I hold down my control key and scroll forward on the mouse wheel, I can just zoom in on that script to make it a little bit easier to read. So I've loaded in the first grid. Now I'm going to load in my other one. So for this next one, I'm going to call this my key thickness. Click open. I'm going to grab my key thickness grid. And just like before, it clears out that value and then it actually loads in from this directory. The next thing I like to do is I like to put some spaces between what I'm loading in and what I'm actually calculating. So you can just press enter to jump down to new lines just to keep things kind of clean. And now I'm actually going to perform my calculation. I do have buttons over here to help guide me on the calculations, but sometimes I find it's easier just to manually type it in. So I'm going to type in a new variable for my stripping ratio, show how we're going to structure this equation. The new variable name will just be SR for stripping ratio equals, and I'm going to refer back to my equations here. I'm just going to write out this equation very much how it looks here. So I'm going to say my stripping ratio is the waste thickness times 2000. So I'm going to type in my OB thick times 2000, making sure that this variable name matches what was already defined. And then I'm going to divide by, put a left parenthesis for grouping terms, and I'll do my key thickness times 27 times 80. Times 27 times 80. And sometimes there's an advantage to leaving the original values instead of just a compressed conversion factor, because this makes it a little bit easier for somebody else to review my macro, and when they see a 2000 they might think, oh well, that's the conversion from pounds to tons, so they can follow along with that a little bit easier. And if you like, you can actually add in some notes here. So if I jump down to the next line and I start the line off with a semicolon, that tells the program that anything that follows is just a comment. So I could type in 2000 converts pounds to tons. I could do another line, semicolon, and say the 27 converts cubic feet to cubic yards. And I could say 80 is the key density, converts cubic feet to pounds. So you can add in all those little notes there that you like. But going back to our original reason for having to jump into this macro editor, we have problems when the key thickness gets to be 0 or even just very, very low. We get a stripping ratio that just goes through the roof. So in this case, it might be sensible to say that whenever the key thickness gets below maybe a minimum acceptable mining thickness, we could just set the stripping ratio to a constant value that's very large, something we know we would never use, just to make the grid readable. So I'm going to do another calculation here for the stripping ratio. And for this one, I'm going to use an if statement. We do have a lot of templates here for all the different functions in the macro editor. So you can just load in one of these templates and you can kind of see how this is going to work. So I'm going to use an if statement here. I'm going to insert that template, and it just writes in some examples for me. So I'll keep that one in there just so I can use it as a guide, but I would want to delete this. I don't want to keep that in there. So I'm going to do another calculation here for the stripping ratio, equals if, and I'm going to write my condition. And I'm going to say that anytime the key thickness is less than 3 foot thick, I'm going to do something different. So I'm going to say if the key thick is less than 3, comma, I'll say then do what? And what I'm saying for the then, I'm actually assigning a value to this stripping ratio variable. So if the key thickness is less than 3, I'm just going to say that the stripping ratio equals 50. Now, of course, it's probably much higher than that, but that's just a constant value I'm going to assume so we don't ever see anything greater than 50. Comma. So if that condition fails, I'm just going to leave the calculation alone. So I'll say if the key thickness is less than 3, change SR to be a value of 50. Otherwise, just keep the original value assigned to SR. And so I can put in another note here, say this assumes a minimum key thickness of 3 feet. So just a simple way to modify the stripping ratio grid in a way that we couldn't do it with the quick-by-quick solution. And then finally, I'm just going to save my result. I'll click Save As, and I'm saving the grid variable SR. And I'm going to call this one stripping ratio 2, just so I can compare it to the quick-by-quick solution. So it's in there. And before I actually run this macro. Up to this point, I've just written the script. I haven't actually created anything yet. I've got a values drill down section so I can inspect the progress. If I hit the pick button here, I can click a point on the map and inspect the values as this macro runs. Now, I know in my case, down in this southern area, this is where my key thickness starts to zero out. So I'm going to use that. And I'm going to click Start. And it tells me here that I do have an error in the macro. So yeah, I forgot to remove my template. So I'm just going to select that template that I had in there and just delete it out. And I'll rerun it. So it's good to see that. So anytime that the macro has a problem, it'll tell you that it doesn't know what variable you're referring to or something's undefined. So with that removed, let's try it again. Start it, and great. This time the macro completed. And I can see here in my values drill down, it starts off, we've got a null, so the first time it sees my overburden thickness, there's nothing defined for it, but then it loads it in, and that thickness is at a value of 73. It loads in the key thickness, and in that area it's 0. And just it then gives me my final readout for the stripping ratio, which is 50. So, you know, my logic held. I was less than 3 thickness on the key material. My output became 50. If I pick another location, maybe somewhere over here, run the grid again, I can see that time I had positive values for my key thickness. Stripping ratio came out to be close to 13. So this is a nice little tool just to inspect your numbers. You can manually check it. And so finally I'm just going to hit Save Macro here, exit, and let's go look at our grids in the 3D viewer. Surface File Viewer. I'm going to first load in my original stripping ratio grid. So this is the one that we did click by click. It's got that spike in there, really large values. Then I'm going to load in the stripping ratio 2 grid, and we can see that's actually filled in there, so we don't have any crazy spikes. And if I turn off the first one, now we can see we've got just nice values filling in, no crazy spikes or anything like that. The last quick example that I'm going to show using a grid file macro is we are going to calculate some diluted quality of our key material by adding in some waste material. So I've actually already got a macro written for this one. I'm just going to explain it rather than go through this step by step, just to give an idea of some of the things you can do. So what I've done here is I've loaded in my full key thickness grid, and I've loaded in the moisture grid that defines that strata. Now I don't have a grid file for the amount of waste I'm going to dilute, nor do I have a moisture content of the waste material. So what I've done is I've just simply defined those with constants. So here I'm saying I'm going to use 1 foot of overburden thickness to be diluted in. And I'm going to assume an overburden moisture content of 10%. I'm going to use all 4 of those variables to write my diluted quality equation. So this is just a simple thickness weighted average where I'm taking my key thickness multiplied by the key moisture. To that I'm going to add my overburden thickness multiplied by the overburden moisture. And I'm going to take all of that material and divide it by the combined thickness. It's just a very simple thickness weighted average. And to show the values that I'm getting out here, I'm just going to pick a location somewhere on the screen, start it, and you can see with these assumptions I'm getting a diluted quality of about 29, whereas the original moisture content was about 31. So this is where I can kind of play around with some values for a what if analysis. So what if I diluted in 1.5 feet of material and I assumed a moisture content of about 15%. So if I start that, get about a 29. If I assumed a overburden moisture content of, let's say this was a very wet material, so we assume 50% moisture, just This time we're getting a new diluted quality of about 33%. So this just shows that we don't have to have grids for everything. We can define constants, and we can write equations really however we need to. The sky's kind of the limit with grid file utilities. And in closing, I'll encourage you to explore the other options that we have in this command. This video is really just a subset of all the functions, but we do have complete documentation of this command in the help manual. You're always welcome to explore that. Or if you have additional questions, you can reach out to us at info@carlsonsw.com. Thank you for your time.